So let's start from the beginning. We have the person class. We've created the person class here, and we've given the name, gender, and age and children attributes to person. We also have the constructor. You already know how the constructor is created. And then we have some methods. We specifically have the getter and setter method for children. And these are the methods that we'll focus on. Currently, we are seeing that there is a problem with the setChildren method. What is that problem? Let's understand that. The way that this is defined here can be better, and this is not fully encapsulated. So how do we fully encapsulate it? For that, at first, we'll need to understand what the problem is. Let's look into the main method first and see what's going on there. So at first, we've created a children array, and that is a string type array. And this array has the value Mary, David, and Eric stored in it. So what does it look like in memory? Let's say this is our memory, and let's say a small part of this memory is where Mary, David, and Eric, this array, is stored. So let's say this is that small part of the memory, and the array Mary, David, and Eric is stored here. What is stored in children? Children is basically another 32-bit memory location where the address of this big memory location is stored. So that's how it looks. So this children is basically this one here. And here in this children variable, this address is stored. And this address is basically pointing to this big memory location where the main array is stored, Mary, David, and Eric, which are the values that are stored in children. So this is how the children array looks in the memory. There's a 32-bit space where the address is stored, and that is stored in the children variable. And that address basically points to the main memory location where Mary, David, and Eric are stored. So we now understand what children looks like in memory. Great. Now the program comes here. It sees that this is a new object that is being created. It is from the person class, and this is the constructor. So the program thinks, all right, where do I go? I go to the person class and go to the constructor method. So the program comes here. So you already know what's happening here, right? What happens is the name John basically comes here. So this variable here has the name John in it. That's the string that's stored in this variable here. And then this variable is the same as this variable. And this variable is the same as this variable. So ultimately, what do we want to do? We want to make sure that the value of the name variable for P1, which is this, we want the name variable for P1 to be John, right? We want this to become John. So what happens is this string John comes here, and this variable now has John stored in it. Now we say that this dot name, which is this variable, remember whenever we are looking for the instance variable, we use the keyword this. So this dot name basically means this variable, right? And so this dot name gets assigned to this variable here, name. So John comes here to this variable, then this comes here, and then this get assigns to this, which means ultimately that this variable became John for P1. In the same way, male as a gender comes here, and we get this variable by using this. And then we assign this variable here to this variable. So male came here, now this has male, this then came here, and this has male, and this got assigned to this dot gender, which is this, which means that now gender is male. The same thing happens with 20. This comes here, and we take this, and this means this variable because we're using this keyword. So 20 comes here, this value is 20 right now, and then this comes here, and this value is 20 right now, and 20 gets assigned to this dot age, and this dot age is this, which means age for P1 now becomes 20. So in this way, we've assigned John to name, we've assigned male to gender, and we've assigned 20 to age using this constructor. And all of this is for P1. For a different object, all of this would be different, right? But we're talking only about P1 right now. Great. So what about children? What is stored in children? When we say that P1 equals new person, John, male, 20, and children, what does children really mean? What does children have? Children is supposed to have these three variables, right? But that is not correct because children is a non-primitive type variable. It's an array. So this is passed by reference. This is not passed by value, which means that children does not have Mary, David, and Eric in it. What children has is this address in it, right? So ultimately, when we say children, what we're passing here is basically the address. This address is coming here, basically. And so through the constructor, this value comes here. So now this becomes that address. Then this value comes here, and this is now the address. And this gets assigned to this dot children, which is this. So ultimately, this becomes the address. So how does this look in the memory? In the memory, there is another 32-bit block, and that is this children, right? So let's color it differently. That is this children, right? And what's stored in it? The same value that's here, right? So the same thing gets stored here. So now you see these two are two different memory locations because these two are two different variables. This children is basically the variable here that belongs to the person class. This children is basically the variable here, which is an array in the main class. But what's stored in both of these two variables? The same address is stored in both of these two variables because we just showed that this value got passed here and then this got passed here and ultimately this became the same value, right? So if you really think about it, what is this address pointing at? It's pointing at the same array. And I hope you understand now that that is a problem. Because if we change children, let's say we don't even touch P1. If we change children somehow, P1's values would also change because changing children means we're changing this part. So if we change children, this part changes. And because the children here for person class is also pointing to the same object, the person P1 also feels the same changes. And that is a vulnerability. That is a weakness. So that is one of the problems that we discussed before. So we have to be very careful when we put non-primitive types in constructors. And we'll look at how we can solve this. But let's also look at the setter method for children. The problem also exists there if we define it this way. And we'll draw that diagram right now and show you how that problem also is there. So we'll draw it on this part. We'll keep this here for now. So let's look at the setter method. What did we do here? We created a new array and we assigned 3 values there: Mary, David, and Grinch. So what does this look like in memory? We have a memory block here, and in there, Mary, David, and Grinch are stored. So great, this is the memory location where our array is stored. What's the address of this memory location? So let's say that's the address where the new array's values are stored. But what about new array variable? That is stored in a 32-bit memory. This would be new array here. So we'll write new array, which is from main. And what will be stored here is basically just the address where it's pointing to. So it's pointing to this address, and that's where Mary, David, and Grinch are stored as values. So this address will be stored in this 32-bit memory. So now you understand what new array looks like in memory. This is the new array variable. It stores an address. That address points to the location where the values are stored. Now the program comes here. It sees that we are looking at P1, so this particular object, and we're using the method setChildren. And this is what we input here. So what are we basically passing? This new array stores what? This new array stores this address, right? Not necessarily these values. So this just stores the address. So the address is being passed here. So the value that's being passed here is this. So because this is a method and this is the parameter, the program now goes and finds this method in the person class. So this comes here, which means input children now has this stored in it. What does input children look like in memory? Again, it's a 32-bit memory, and what it stores is this value. And this is input children from the person class. And you see, this being the same address as this is basically pointing to the same object. Only one object exists, and this is that object. This is the array object that exists. These are just storing the addresses and are pointing to that object. So now we're directly passing the reference of this object to our input children variable. Now this then comes here and this gets assigned to this dot children, which is basically this variable. So now our children variable becomes this value. So this is what is stored in our children variable. So now you understand that our input children variable was pointing to this array. What about our children variable? Previously, our children variable was pointing to this array. But now because we changed the assignment, we now assigned input children to children, and now children has become this. This value would change because we assigned a new array to children using our setChildren method. right? Previously, the assignment came from here, but now we changed it to new array and assigned new array to our children. So this would change to this new address, which means now that this connection would not exist because this is not pointing to this address anymore. Instead, this would now basically point to this array. Again, remember, there's only this one object here. The only different objects that we created are these two different objects. Everything happening here is just changing of addresses and which address they point to. So let me remove this. So now remember that this children part is an attribute of our person class. And we want to encapsulate everything inside the person class, including this children variable. So we are really concerned about this variable here, and we want to encapsulate it correctly. So which variable is this in memory? It's this variable here, right? So we want to make sure that this variable is controlled, and then nobody else from the outside can actually control it. But if you really look at the diagram right now, you do understand that if I change new array, which means I'm changing this object, and if my children variable also points to the same object, that means that this is vulnerable. Because if I change new array, which has nothing to do with the person class, new array is from the main class. If I change new array, then I'm changing this object, which means that my children variable also gets changed. My children array also gets changed. And that is the problem. And that is exactly what's happening here. When I change new array 0 to squirrel, what am I changing? I'm changing the new array variable's first element. So the new array basically is this address. It comes here and it changes this first element to squirrel. So that's what we did here. We changed the first element of new array to squirrel. And what it did is change this object. Now, when we are printing out the children of P1, which is get children, and get children is basically this, and this is basically this variable. When we're trying to print whatever is in this variable, look at the memory. This variable also points to the same object. So when we print it, our result is Squirrel, David, and Grinch. But we don't want that. We want it to be Mary, David, and Grinch. The change that we did here, we do not want this to affect our class variables. We want to encapsulate it even better. So you see this is leaking. It's not encapsulating correctly. So this is what we did. We changed this whole method where we're creating a new array, and before we make this change, we're copying everything from this array to our new array, and that is what we store in children. Let me explain that using this diagram. So remember that we're changing this whole method, right? What do we change it to? So now we have changed our setter method to this. What's happening here? Let's shift this a little bit to this side so that we have more space. There you go. And let's start from the very beginning. What's happening? So at first we create this new array, and this new array gets created here. And this has Mary, David, and Grinch in it. The address of this object is this, and this is the new array variable where this address is stored. So this is pointing here. Let's remove all of this for now, and because these connections have not yet been made, right, in our new program. And of course, these addresses have not yet been assigned. So there you go. At first, we created the new array and we stored Mary, David, and Grinch in it. So the new array variable is here and it stores the address where the actual object is stored, and the actual object is stored here in this memory location. Great. So this is what we have up till now. Now we say p1.setChildren new array, right? What is new array? New array is basically storing this address. So what's here? It's this address. Great. So now that we are assigning this as the parameter, then this also has the same address. So ultimately, this comes here, right? And this is the parameter that gets assigned to input children. So now input children is the parameter for the method, and this is the parameter that we're inputting. So this comes here. Now input children becomes the same address. Great. So now input children has the same address. But what are we doing here? Let me remove this. What we're doing here is that we're first selecting our children variable from here, right? We use the word this. So we're actually interacting with this variable right now. So this.children does not get assigned to input children directly like we did previously. We are assigning a new string array to this.children. So this is a completely new array. This is a new string array that we're creating, right? So let's create this array. And of course, this will be a new different object. So what would this look like in memory? This new string array. So this is what happens. A new object gets created. It's empty. There is nothing in there right now because we did not assign any values. We just said that this is a new string array object. So this is the new string array object, and children stores this address now. How many elements can this string array store, the same as the length of input children. So what is input children? Input children is this address, right? So this is what's stored in input children. And so this address in input children is the same as that of new array. So this is pointing to this object. So input children's length is whatever the length of this object is. And the length of this object is 1, 2, 3. The length is 3. So input children length is 3, which means that this new string array that we created, the new string array object, will also have a length of 3, which means that it will also be able to store 3 different values. What we then do is that we copy everything from input children to this dot children. So we're copying everything from input children, which is this object, to this dot children, which is this object. This children is this address, right, which is this. So it is pointing to this object. So everything from input children will be copied to this dot children. Means input children is this object, this dot children is this object. So everything from here will be copied to here. It'll start from 0. So the 0th element gets copied first. And now we have Mary here. Then the first element is copied. And now we have David here. And then this keeps on going until input.children.length. So this would go from 0 to 2. So 0, 1, 2. This is 0. This is 1. This is 2. So this will go from 0 to 2. So at first it starts from 0. So the 0th element gets copied. Then the 1 element gets copied. And then the 2 index element gets copied. So this becomes Grinch. So now the copying is done, which means that our children variable in the person class has this value stored in it. So this would be this value, and this value is the address of this object, and nobody has access to this object except for our children variable. So the program is done up till this part. Now the program comes here. Previously what we did is that we created the new array, it got created here, and then we used the setter method for our P1 object and set the new array as the new children for P1. What that did is it took this to input children, and input children was this. The same address got copied, and then we actually created a new object here. We copied everything from this object to this object, and then pointed our children variable to this new object. Nobody else has access to it, only the children variable from our person class has access to it. Great. So now when we come to this part, what happens is that we change the first element of new array to squirrel. So the new array is basically this object, and so this gets changed to squirrel. And now when we print all the values of our children variable using the getChildren method, what getChildren does is that it returns children from here, right? So ultimately we're printing everything here and not here. So now our result for this part of the code will be Mary, David, and Grinch instead of Squirrel, David, and Grinch. So now you see we have encapsulated our children variable, because now the children variable itself has its own object, and it is not pointing to some other object that anybody else can change. It has its own object, and that own object has its own memory where the different variable values are stored. So summarizing, whenever we use setter methods for non-primitive types, we should never just say this dot whatever variable you have that is non-primitive, let's say x, equals whatever is input, so input x. We should never do this. We should always create a new array, copy everything there, and then point our non-primitive type variable to the new array. And that's exactly what we did. So now you understand why the setter methods that we wrote before had a problem and how we fixed that problem. Thinking of the concept of encapsulation. We want to encapsulate the children variable, make sure that it is airtight, and now we have made it airtight. Nobody has access to this object. Only our children variable has access to this object. And so now you know how to think of encapsulation whenever you're creating setter methods for your non-primitive data type variables. And this is exactly what we showed in the code before. But having this pictorial representation, these diagrams, I hope this is a lot more clearer to you.